Okay, it looks like I'm all set. I've got my tea ready to go. Probably sip on that as we talk. So let's get going. All right, so I am Paul Jones, and this is a session on how an extension is created. We're going to be talking about the process that we go through here at Configura to develop and maintain the extensions that you use, as well as a little bit about the programming, like how that works, or how we think about it at least. Gonna real quick give myself a little bit of a background. So I started at Configura in 2012. I was working on what we called production for 6 years. So what we now call customer delivery, the team that actually worked on these extensions, these manufacturer extensions, product extensions, however you want to think about it. I was working within our R&D team for about 4 years. I was doing catalog creator training for about 3 years, developer training for 7 years. I was working a little bit with developer and user support for 3 years, and most recently I've been working as a product owner for developer experience for the last about a year. Right, obviously, there's some overlap here to make all that math work, but really point I'm just trying to come across with here is that I've looked at programming within Configure from a lot of different angles. I've done it, I've trained on it, I've documented on it, I've even done all those things for adjacent things like data catalogs, and now I'm part of a team that actually works on the tools that developers use. So yeah, I've from every angle I've been looking at the developer experience. Oh, excuse me. So right, this is going to come in two parts basically. This session will be split up into two sections. The first section is going to be talking about the actual the process that we go through, the way of working for doing extension development. And then the second part will be on the actual like programming, the development part of this. Um, so, right, we'll start with our actual process. So we follow a what's called an agile methodology, specifically one called Scrum. Um, Agile in general is a Agile is a pretty rough description, a pretty distant, abstract description of a way of working for initially for software development. Now, in time, it's been found that this actually works well for other types of work, different work situations, but initially was designed for software development. Scrum is a specific kind of agile methodology that was concocted a little bit later. Um, it is ideal as a way of working your when the work that you're doing has some kind of end result, end product, end thing, a thing that you can hand over and point to and say, we did that. This makes sense for products, obviously, but it also makes sense for software in that we can point at a specific feature or something that's been programmed and say that's what we did. Um, it also works best for a body of work that can be broken down into a series of small tasks. The smaller the possible. The smaller, the smaller the better. Sorry. So, and this will become more obvious later, but having that kind of granular description of all the work that needs to be done is important to doing agile stuff. So, agile is all about an iterative refinement of goals. Basically, what it means is we recognize that at the start of a project, at the start of a body of work, maybe we're talking about a product line. In fact, I'm probably going to keep referring back to the development of a product line just because it's an easy way to talk. Um, uh, the initial understanding of that body of work might not hold true for the entire development timeline, right? Or we might need to change how we work, what we're working on, what we do for some amount of time. We might realize, ooh, that's not the best way to do that, or that's not actually the best way to provide value to our users, or who knows, budget changes. There's all kinds of things that can change over time The idea with Agile in general is that we're constantly coming back and reviewing what we've done so far, where we are in the full scope, and all of these things, and adjusting as necessary. In the past, prior to Agile as a general way of working, the way software development tended to work is there was some initial planning time where we threw all the bodies in the room that we could think of, anyone who might be invested in this outcome, usually, but not always, some of the developers would be in the room, and we'd just bang out everything that we could, and then we just work from start till done. And it's not until the end that we actually came back and says, all right, was this good? Did we do the right thing? And that had fairly obvious problems. If it turns out our understanding of the initial requirements was wrong, then we just wasted 3, 6, 12 months developing something wrong. Or maybe that timeline doesn't even work. And halfway through a project, you realize, oh, this is taking way too long. We can't afford this, and then drop the project. Like, any number of things can go wrong. If you just say, describe the thing to do, work for the entire time, then we're done. Like, it doesn't work. So Agile is all around iterating. Do a little bit of work, reevaluate where we are and where we're going, iterate again, just keep repeating that process. It makes it very easy to adapt to changes. Maybe it turns out one of these features that was requested is actually really hard, and it's going to take more development time, so we can reevaluate whether or not that feature has enough value for the time. Maybe our understanding of a product was incorrect. Maybe budgets change. That happens, for better or for worse. Any number of things can go unexpectedly, but because we're iterating, because we're doing our work in small chunks, taking off these little bites, we can, within a small amount of time, adjust the goal. If we're going down a direction that's not good, we can steer the ship back on course, or we can, if we need to cut out some features or maybe even add some features, maybe we're really crushing it and we've got a lot of extra productivity that we didn't plan on. Well, then great, let's talk about refining some things further. We can do those adaptations very easily. We're constantly refining our optimal output. We're constantly moving towards the optimal output. Right, so this is sort of the mile-high view of Agile and sort of Scrum as well. So what I'm going to start diving deeper, basically. We had this mile-high view. I'm going to go a little bit deeper by first talking about the different roles that we have on a development team. One quick thing I'll point out, this is kind of a, well, actually, kind of a moment here, but one of the things that makes Scrum so cool as a way of working is that it's designed to be adaptable to the team as well. So you're not just adapting the project over time, you're also adapting the process over time. Or you can think of it kind of like monopoly rules for how you work. Scrum lays out a list of, say, rules or things you should do or how you should do them and all these things, but they come right out and say, take the pieces that work, leave the pieces that don't. If a certain part of the process doesn't work for you, either adapt it to make it work or just don't do it. So what I'm going to be describing here is the form of Scrum that the customer delivery team here, Configura, has come to over time. So this is sort of our own flavor of Scrum. This is sort of the house rules of Scrum that we work through. So some of the terms are not like academically correct or tied directly to official Scrum terminology. These are our little tweaks. Right, so let's get into it. The different roles that take part in Scrum. Scrums take place in small teams. Everyone on the team has a specific role that they play, a part that they play in the process to getting us towards the optimal end goal. We'll start with the project owner, or sometimes the product owner. That I'm going to actually use the terms interchangeably because the way we work, they're kind of the same, kind of not, but close. The project owner is the person who owns the project. And by what I mean by that is they're the ones who are requesting the work be done. They're the ones who describe the work being done, and they're also the ones who can own up to, yes, this is good, no, it's not, or this is quality, or it's not, or all of these things. This person is almost 100% of the time someone who works for the manufacturer. So the manufacturer, the organization who's requesting the work be done, is a project owner, which makes sense. They're the ones requesting the work for us, so they're also the ones who will, review our progress as we go and make sure that it's good or bad. Well, good or bad, right or wrong, ideal, non-ideal, whatever. That's the project owner. We also have a project manager. Now, in traditional Scrum, there is something called a Scrum Master. Our project manager is that and a little bit more. A Scrum Master's responsibility is to make sure that Scrum is done correctly and effectively. So all this process that I'm talking about has a lot of bits and pieces to it. It has a lot of like steps. It has certain meetings, or sometimes referred to as ceremonies, even though we're not supposed to anymore. Has a lot of, I don't want to say bureaucracy, but kind of. Like there's a lot of process. There's a lot of things to keep track of to make sure that Scrum is happening correctly, and that is a Scrum Master's responsibility. They're sometimes referred to as a team coach or a team facilitator, in that they don't directly contribute to any of the work themselves, but they're sort of the enablers. They're making sure everyone else can focus on their responsibilities and just work as effectively as possible and try to keep all the distractions away from them. The project manager, this little bit that we tack on to a Scrum Master, is also because of the relationship between Configura and a manufacturer, we need to have a kind of a day-to-day point of contact between the two of us. So the project manager will do that. So anytime we need to discuss something with a project owner that's Scrum related, the project manager does this, but also sometimes things that go a bit outside of the scope of a project manager will sometimes facilitate that too. Well, that or one of our account executives. So yeah, it's also, in addition to a Scrum Master, it's also kind of a bridge, a coordinator between Configura and a manufacturer. Quality assurance specialists or quality assurance analysts, we use both terms, they do what they say on the label. They are here to make sure that the work we do meets Configura standards for quality, and in some cases, where they have the training to do so, they will also speak to the standards of quality that the manufacturer requires. This isn't super common, but it happens, and it's actually pretty nice when it does happen. If a QA has enough understanding of the manufacturer's needs in terms of quality and I guess whatever other requirements they have, we can actually have those requirements be considered early in the process during the day-to-day work, which means that we can get that kind of feedback quickly and save a lot more time and so on and so forth. And then we've got the developers. They're the hands-on keyboards. They're the one doing the programming. They also will create something we call builds, which we'll talk about later. They're doing the majority of what you would call work. All of these roles are doing work, but if you were to talk about the most like actual like boots on the ground, making production happen, that's the developers. If we're talking about an extension that uses catalogs in the background, and you may or may not, as a user, you may or may not even know when that's happening, but not everyone who does work on extension is a developer. Sometimes there's also catalogs at play, in which case we also have a catalog specialist. Although we tend to lump them together as developers because it's kind of the same thing in terms of the process. There's a requirement that comes in, some hands the keyboard, gets done, some work goes out. So whether it be a programming type of developer or a catalog specialist, we tend to call them just developers. Okay, so what are some of these processes that have been talked about? Well, there is the project start, and then there's the like day to day. We'll talk about the project start first, and we'll slip into the day to day. When we're going to start a new project, say it's a new product line or a new model or something like that, it starts off with a meeting between the project manager and the project owner. And there will often be others in the room as well. Maybe you have SMEs or engineers or heck, marketing and sales might be in the room for some reason if they feel that their input is necessary. Um, but at the very least, we have a project owner in the room, and a project manager in the room, and they will work together to itemize all the work that needs to be done. Now, this is this is the first time we've actually started talking about the work that's going to be done. So this might be the different products that we want, it might be the different features we want, it could be whatever, but it's the different things that the project owner is requesting be done. Um, in addition to that, we're talking about the behaviors of these things, the appearance, the rules. How are they compatible with other things? What are their interactions with other things? Do they have any special functionality for CET, for exporting? Whatever. All the details about what this thing is and how it should work inside of CET is fleshed out at this point, or at least as best as we can. Uh, Wrong button, sorry. At some point, we bring in a developer from the developer team, often someone we refer to as a lead developer. He's going to come in, well, he, she, they will come in and do another check to ensure that all the requirements that they need are spoken for. They're going to, I keep pressing the wrong button. I swear I'm not doing it on purpose. They're going to go through all of these and make sure that all the information that the developer needs to complete that task is accounted for. We try to get this done during the project start so that we don't have to ask questions later. Remember, at this particular meeting or set of meetings, we hopefully have everyone in the room who can answer questions. SMEs, engineers, designers, whatever. So the project manager and the lead developer can ask whatever questions they need and get answers right away. We can hopefully get this all out in front and understand as much as possible up front as we can. I had said earlier that trying to get everything perfectly described up front is kind of impossible. It's kind of a pipe dream, and that's true. We're always going to discover new things. The requirements will always change, but the more we get done at first, the better we're going to do. The least adjustments we're going to make, the least surprises, all these things, least stress. So we try to get these things hammered out in as much detail and as much completionness. We try to get it all worked out in advance. And so this is the time to do that. Now, at this point, Configura and their team will come back and they're going to look at the tickets by themselves and they're going to start talking about what the actual tickets are going to be. So at this point, we've been talking about these things in details, yes, but in a form that's most convenient for conversation, right? We've been discussing these things maybe just on pen and paper or whiteboard somewhere, or maybe just like a product catalog or something with some, some sticky notes in there. But we need to get these broken down to actual units of work, which may or may not be the same thing. Often yes, but not always. Say these three products I have on screen here that that we worked out together. To a project owner, these are three clearly distinct things. There is, in this case, a pedestal, there is an office chair, there's a freestanding table. But to a developer, that might be actually four different bodies of work. That table, the developer might say it's easiest to think of, the tabletop as its own thing and the support as being its own thing. We'll do just both of those, and then together we'll have the finished goal. It works best when we can break things down into smallest units of work. It just makes things flow better. So that will happen next. And then we just get those translated into their final form. So this is where we if we actually have, say, a form where we put all this stuff, we'll do that. In our case, we use a piece of software called Jira. In case you haven't heard of it, it's I guess the shortest way to describe it as a piece of software that takes care of all the paperwork of Agile or Scrum, right? We want to keep cards for each of these things. We want to record all the requested features. Maybe there's associated pictures or references to, PDFs and stuff. It collects each of those into their own cards and puts them all in place so that we have a nice one-stop shop for each body of work. And that'll be the last thing we do. I warned you I'd drink that tea. You didn't think I'd do it, but I did. Okay, so that's the project start. We've gone through all the body of work that we want to have done. We've described it in as much detail as we can. We have, pen and papered the crud out of it, and now we've got nice, neat, convenient cards, independent units of work. So how do we actually do the work? Well, then we get into sprinting. So in Scrum, you work in these iterations we call sprints. A sprint is just some fixed amount of time. No real hard rules about how long it should be, although we almost always choose 2 weeks. This is just a span of time where you're going to choose a number of those cards, those tickets to work on, based on the amount of time and how long we predict each one of those will take. We send those through our workflow, which I'm going to describe in a little bit. And then at the end of the sprint, end of those 2 weeks or however long it is, we're going to look back at the work we've done, and we're going to just do a review of our progress. Are our estimates very high? Are they very low? We'll meet with the project owner or the product owner. We'll discuss, are these things of good quality? Are these what you imagine they would be? Do you want to change your mind on anything? Please don't, but it can happen. And so, yeah, we just review what we've done so far and where we're going, and we're making sure that we're on track. And this is also the opportunity where we can make adjustments. If it's turning out that these things are taking longer than we expected, it's an opportunity for the project owner to say, I really wanted to hit that timeline. I really wanted to hit that release date. So maybe we need to cut these other features in order to get it released on in time. Or, we did the feature this way, but I think users will actually like it a lot more if we did it this way. And so we can make those kinds of adjustments as we're going. Adjustments do come with costs, of course. Anytime we change, we risk losing some of the work we've done, or I guess that's the biggest one, but we can do it. The point of this isn't to eliminate the cost of changing our path or changing our way of working. It's just to reduce it as small as possible. We're only working for 2 weeks at a time, so in theory, the biggest risk is that we lose 2 weeks of time rather than that big 3, 6, 12 months that we talked about before. So yeah, the team, the project owner, everyone, we're all working towards optimizing our work towards the ideal output at the very end. And we're doing it in little bites so that we can make micro adjustments, we can react to changes very quickly, and reducing the impact of those surprises. As a pleasant side effect, this also makes the team more predictable over time. This might be a kind of a weird thing to consider, but this is actually really important for development teams. Software development is inherently very hard to predict. A lot of programming is really just figuring out what to do, as strange as that sounds. Programming is just describing what the computer should do. So the majority of the work is just figuring out what to tell it, right? So if we knew with 100% accuracy what we're going to do, well, I mean, that is the work, right? So then everything would be zero length time if we just knew what to do. So it means every piece of work we do, the time we're estimating is, in a way, the time it's going to take for us to figure out what to do. in a way. And because it's unknown, we can't predict with 100% accuracy, but that can have pretty serious consequences. If we are estimating very low for all our tickets, that might mean we're going to blow past some release date. If we're predicting too aggressively or too defensively, that might mean that we could have done much more before or potential release date or something like that. There's all kinds of things that can go off here. By making the team more predictable, it improves our ability to hit timelines as planned, and it also means we have much more warning before we're not going to hit an important milestone. If we know we're not going to get a certain release date in time well in advance, that gives us way more room to adjust. So it's a very important thing. Okay. So this workflow, what is the actual workflow? We got these tickets coming in, we're working in sprints, but what does a sprint actually look like? So this is where we're going to get into one of my fancier PowerPoint animations. In fact, I'm going to get some tea first so I don't spoil it. Okay. So what does a sprint workflow look like? So again, this is that 2-week span of time where we're doing work, and then at the beginning we grab some tasks, we decide what we're going to do based on how much time we have and how long they're going to take. At the end, we look back at what we did and we adjust. But what does the actual workflow for an individual card look like? Well, it starts off by we give it to a developer, and he's going to review that card to make sure it's in a good state. So this is another review. I think this is like the third time we actually review a ticket to make sure it's of good quality, complete, has all the details we need. We check so often because the cost of checking is so little compared to getting it wrong, right? If we get something wrong later, we tend to lose a lot of time compared to just making sure. What's it? An ounce of prevention is worth a pound of cure or something like that. I don't know. Anyway, point is we have a developer look at a ticket in advance before we start working on it to make sure one last time that's good to go. We then pass it off to the developer to actually make the work happen. He's going to slap the keyboard for a while, and he's going to turn out some code that makes the product or the feature or the whatever happen. They will then send it over to our quality assurance analyst who will perform quality assurance. They might just look at the thing to make sure it looks right. They may run a suite of tests on it to make sure it's that way. They might be comparing it to a product catalog or something to make sure it's correct. All of these things it depends on what kind of quality assurance you want on a particular project, but they're going to be doing that. Assuming that passes, they are then going to send it over to another developer, or maybe the same developer, I suppose, and they are going to add it to a build. So a build is a bit hard to describe from the outside, so I'm just going to say it's a separate, extra version of CET that is specific to just this project. And we put work in there as we go so that we can review it in in the real world, so to speak. It's typically not effective to hand the project owner every ticket one at a time. So what happens is that we'll have the one developer who is, as work is getting done, he is adding them to this special version of CET. And then towards the end of the sprint, typically as part of that sprint retro or whatnot, that special version of CET, that build, we hand it over to the product owner to review. What happens next depends on the project. If it's something like a product line, which you really want to work until it's all the way done, then we'll just hang on to this build for a while. But if we're just talking about maintenance work, then oftentimes the project owner will just say, great, ship it, and then it goes out to everyone to be used. So again, it's just depending on what kind of project. And that's it for the process. I mean, it's not really it. It's just all I'm going to tell you about. We repeat this whole thing over and over and over again until all those tickets are worked out, and then hopefully we have a really kick-ass extension. We've been reviewing it as we go, so if we're off track, we get to go back and adjust those tickets or make new ones, remove them, whatever we need to do, and just keep iterating. Programming. That was a big one. So obviously, it's kind of hard to sum up a bachelor's degree in 30 minutes. So we're only going to hit on some of the more distant, kind of interesting stuff. Programming extensions. So we program in a programming language called CM. Programming is always, 99.9999% of the time done in a special programming language. Technically, you could go down and, change bits on the hard drive if you really want to, but don't do that. You use some kind of a programming language just being a form of language where you describe what the computer should do. At some point, that language will get translated into the ones and zeros that the computer understands, and then we'll do those instructions. We have our own language called CM. I won't get into the hows and whys of why we made our own programming language. It's not a common thing. And like I said, the hows and whys get into a lot of details that are probably not interesting for this kind of discussion. So moving on, it is an object-oriented programming language. So human languages tend to have, I won't say biases, but they tend to have a focus. If you look at different languages for different countries around the world, you'll notice that some of them tend to focus on certain things. Some languages might tend to have articles that are biased towards certain genders, or have special words for things based on whether or not you are an adult or a child, for example. Different languages have different ways of just framing things. Programming languages take that to an extreme. Programming languages have a way that they expect you to describe what you want the computer to do. There is something called procedural-oriented programming, meaning that it's just computer do this, computer do this, computer do this, just a series of instructions. There's a lot of different paradigms for programming. The CM programming language uses something called object-oriented programming, which means we describe what we want the computer to do in terms of things, objects. The entire world, if you will, is described as things, what they do, what they are, and what their relationship is to other things. So when we're programming, the actual thing we're typing out into the CM source code is a description of the different things and what they are and how they relate to everything else. Of all these different paradigms that are available to us, Configura chose an object-oriented programming paradigm. I'm just going to say OO from now on. It's getting exhausting. We chose OO just because it's easy to understand. For someone who is new to programming in general, or someone who's new to a programming language specifically, it's very easy to say, look, just describe the thing in code and you'll be fine, right? It's a very easy concept to wrap your head around, so it's very easy to onboard new developers and explain to them how to program extensions or stuff inside a CET. So what the majority of the rest of this presentation is going to be about is a little bit about what I mean by object-oriented programming. So let's say you want to program into a piece of software a dog and a cat. And you describe them in terms of their qualities, right? They both have 4 legs, they both have fur, dogs like humans, cats, question mark, and they make different sounds, right? If you were to hand these requirements over to a programmer, an experienced programmer who is used to object-oriented programming, he would say, great, I understand what you mean, but I'm not going to program it that way. One of the advantages of programming in terms of objects is those objects can actually be defined in terms of other objects. You wouldn't, even in the real world, when you describe something like a dog, you're starting off with certain assumptions, right? It's an animal. And animals have certain traits, like they probably breathe and they probably reproduce and all of these things. So, and those things are just kind of assumed. In object-oriented programming, we actually do the same thing. We wouldn't go through all the effort of describing everything that constitutes a dog and everything that constitutes a cat, because we could instead just start by describing an animal and then define the cat and the dog in terms of the animal, of an animal. Leave the things that are specific to dogs and cats in those descriptions. This is a feature we call, well, depending on what we're talking about, it could be different things. I'm going to call it inheritance. It's also related to something called polymorphism. Doesn't matter. Point is, a lot of the programming, object-oriented programming, is describing objects. If they have a relationship between them or some kind of common heritage, we describe the parentage, and that creates these sort of like a taxonomy of things in code, and that's what we're programming. It's these things, the relationship to each other, and as well as what they are and what they do individually. So let's get a bit more specific to programming extensions. So in the code that all developers have access to when they're programming, there is this thing in the code called a snapper. There's this object called a snapper. Think of it kind of like animal in that it's not specific. It's just sort of a rough description. It's not actually like as a full term, a full thing. It's not finished yet, but it does cover a lot of bases. It does explain a lot of things. The snapper object defines a thing that can put line items into the calculation view. It can have graphics. It can like snap to other things. It's just a thing in the drawing. When you're using CET and you're putting stuff in there, those are all snappers, mostly. So a programmer will start with that and say, all right, let's start filling in some of the details. So let's say he's working on a product line of tables. So then he's going to describe an object called table, and based on that, he's going to describe the specific types of tables. So again, you got this kind of hierarchy, this taxonomy of things, each one becoming more specific. The benefit being that if something is true of all, say, tables, you can just describe that in the table, as opposed to describing it in each one of rectangular table, trapezoid table, oval table. Instead of describing it 3 times, you can describe it once. Let's just say all the tables we're working with have these bolt-on legs that bolt onto the bottom of it. We can describe that in the table class object once, and then everything that inherits from that will also have that bolt-on leg quality. But then whenever we have work to do that's specific to, say, the rectangular table or any of these, then we do that work specifically in that type, that class, that object. Their shape. Each one of these tables has a unique shape, so those need to be programmed local to those objects. They each have their unique part numbers or their SKU numbers, so we put those specifically. So at an abstract level, this is kind of what programming looks like. We open up a file. The file says, I'm making a table thing. Tables have maple, oak, mahogany veneer finishes, they have bolt-on legs. Then we open up another file. We say this is a thing called a rectangular table. It's based on that table thing I just told you about, except it has a rectangular shape and this SKU number. And we just keep doing that. We keep on describing things, sometimes just them themselves or their relationship with another thing. Having this kind of hierarchy, this taxonomy, is really nice in that it makes it so we can hopefully minimize the amount of work we actually do. Rather than describing the same thing, the same behavior over and over again, we can just do it in one place, hopefully. Um, it also makes everything nice and organized. If someone requests something be, let's say the project owner, after reviewing the work we've done, has decided that, oh yeah, trapezoid tables, they also have this special electrical harness, right? We know exactly where to put that in the code. We don't have to go hunting for it. Because there's a specific, order of things, a relationship between things, a place where things go. We know exactly where that code needs to be. Excuse me. At least that is until, halfway through, development, project owner comes back and says, "Oh yeah, there was these 12 other things I forgot to tell you about." Then suddenly things get really messy, but life goes on. We adjust. Okay, what comes next? Oh yeah, so this is all nice and pretty and contained and organized, but it has the additional consequence of making us a little bit rigid, um, in a way. What happens when this structure that we set up, this relationship hierarchy we've set up, doesn't actually match reality anymore? What if we learn something later? Or what if, say, we want to do a new product line? Then we have to start breaking this hierarchy, and relationships between things will be changed, and we have to make a lot of, new files, add a lot of stuff to files. Um, we have to write code that has to help users who are opening old drawings adapt to the new code and all that stuff. So there is consequences of working this way. But we do that. That's our job. What else? What else? What else? Oh, so far we haven't actually really talked about extensions. We've been talking about programming. Um, we talk about things and cats and dogs for some reason. Um, what actually is an extension? And I'll tell you the same thing that I tell developers in developer training. As funny as it sounds, extensions are really not that interesting to us. All the stuff we've been talking about, the individual pieces, are interesting. An extension is really just taking those things and putting them into nice little boxes. That's an extension. Um, we take certain portions of the code, we compile it, put it together, we slap a label on it, and we say Fika Office or something like that. And that's what gets put into a build, that's what gets released, that's what you get update notifications for. An extension is just grouping up some code and shipping it. So I think this is about as far as I'm going to be able to pull off in one session. Obviously, I didn't go through everything that goes into programming, but hopefully this gives you a little bit of insight into how it works. I hope that this was insightful. I hope that you can sort of understand a little bit more about how we work, about how we might say certain things, or why we might say certain things. When if you report something to us about, this doesn't work the way I thought, we can say like, oh yeah, it's because it's this kind of snapper when it was meant to be that kind of a snapper. Now you kind of know what we're talking about. So yeah, I think that's it. You're not here, so you can't ask me any questions. But if you want to, you can contact me. I'm Paul Jones. Um, email, I don't have it on screen, sorry, paul.jones@configura.com. But if you want to ask me anything, feel free. Or just, tap on the shoulder of your nearest developer and ask them. We love to talk to users. We really do. Forgive us if we're awkward. So yeah, thank you very much. I appreciate your listening. Have a good day.